Magnetism is a class of physical phenomena that are mediated by magnetic fields. Electric currents and the magnetic moments of elementary particles give rise to a magnetic field, which acts on other currents and magnetic moments. Magnetism is one aspect of the combined phenomenon of electromagnetism. Trivia: did you know that the name magnet came from lodestones found in Magnesia, Anatolia? Because one of the earliest known references to lodestones' magnetic properties was made by the 6th century BC Greek philosopher Thales of Miletus, whom the ancient Greeks credited with discovering lodestones' attraction to iron. And the Englishman William Gilbert was the first to investigate the phenomenon of magnetism systematically using scientific methods. He also discovered that the Earth is itself a weak magnet. Later, he was considered as the father of magnetism. My first experiment is I was using a needle, candle, and a magnet. In here, we'll be able to know if this magnet works better in heat or cold environment, or does the heat affects the polarity or strength of the magnet. Did you know that if the magnet was heated above 80 degrees Celsius or 176 degrees Fahrenheit, it will quickly lose their magnetic properties? The magnet will become permanently demagnetized if exposed to these temperatures for a certain length of time or heated at a significantly higher temperature. And did you know that the candle flame is approximately 1100 degrees Celsius or 2012 degrees Fahrenheit? No wonder why needles fell on the ground. It is because it was temporarily demagnetized due to the candle heat. But why? It's because when heat is added to a substance, the molecules and all atoms vibrate faster. As atoms vibrate faster, the space between atoms increases, so the motion and spacing of the particles determines the state of matter of the substance. Trivia: magnets works better in cold environment. My second magnetic experiment is that I was using a needle, a small cut of paper, a bowl full of water, and of course a magnet. Did you know that you can create your own compass using only those materials? So when you're walking through the wood and suddenly you get lost, this experiment would be a great help. This experiment works when you rub the magnet against the sewing needle. You actually magnetize the needle, effectively making it a weak temporary magnet. The magnetized needle can interact with Earth's magnetic field. My third and last experiment is I was using corn syrup, water, oil, paperclip, and magnet. This experiment, we will be able to know if the liquid's viscosity affect the paperclip to move towards the magnet. In this, we have the lowest to highest liquid viscosity. When using water and vegetable oil, the paper clips move through the magnet quickly. It is because water and vegetable oil have a low viscosity and provide very little resistance to the paper clips moving through them. While in the corn syrup, the paper clips move very slowly towards the magnets. This is because the corn syrup has a high viscosity and provides a lot of resistance to the paperclip moving through it. Though the magnet still attracts to the paperclip, but the experiment shows how the viscosity of a liquid impacts how fast or slow the paperclips move towards the magnet. Thank you for watching.